Okay, so logs are related to exponents because they undo each other, okay? What's the date today? 11/12. Oh, happy Veterans Day. And so you kind of have to get yourself in the thought process of, like, we're undoing or reversing stuff, okay? So, like, if you think about the real world kind of situation, if you put on your winter coat this morning, how many of you guys wear a coat to school? Few, yeah. I see you guys walk into school in shorts. I get cold just looking at you guys. It's crazy. Anyway, but if you put on a jacket, undoing it is taking it off, right? You have to think, of the undoing. If you're opening a door, the undoing of it would be closing it, exactly. Okay? And so when you were in grade school, the first thing, because math builds on each other every time. So the first thing we taught you was how to add 5 to a number. Okay? If you wanted to undo it, then what did we teach you? How to subtract. You would subtract 5, right? And then you learn how to multiply, because multiplying is just fast adding. And then we taught you how to undo multiplying by dividing. Okay? And then you learn squares and how you square numbers. And then what did we teach you? The square roots. Exactly. And then you're probably in the 5th or 6th or 6th or 7th grade maybe, and we taught you distributive property. What undoes distributive property that we did at the beginning of the year that you all hate? What undoes distributive property? We reviewed it at the beginning of the year. We've thrown a few questions on every test.
Oh, factoring.
There you go. I was going to say, you all hate it. But factoring undoes the distributive property. Okay? So, in math speak, adding and subtracting are inverse operations. Okay? Because it undoes each other. Multiplication, division, inverse operations. Okay? Factoring, distributive, inverse. Okay, so thinking about it from when you started learning how to solve equations, if we're asking to solve x, like 2x plus 3 is equal to 5, the actions that are happening to x is that we're adding 3 and we're multiplying by 2. Right? And the actions to undo it, if I said, the actions to undo that would be to subtract the 3 and divide by 2, which is exactly what you do to solve the equation. When you're solving equations, all you're doing is basically undoing PEMDAS. All right, so we subtract 3, and then we divide by 2. Agreed? Then, this year, we took it a step further, and we found the inverse of a linear equation. Okay, go back in your memory banks to, was it last unit, I think? How did we find the inverses of the linear equation algebraically? We had to flip something. We flipped the x and the y. Perfect. Okay? So we rewrote the function with a y. You agree with that? And then we flip the x and y. And then all we had to do was solve for y. So I added 11 to each side. And then divide by 4. And so my inverse is going to be x plus 11 divided by 4. And remember, we wrote it with that -1. And you could have written it as 1/4 x plus 11/4, or you could have written it with it all there. Either way was good. Is that ringing back memories? Yeah? Okay, then how did we verify that it was actually truly an inverse and that we did our math right? Remember this part? You're all looking at me like, nope, don't remember that. Remember how we did the f of g of x, and it had to be equal to the g of f of x? And we would end up with x is equal to x? Remember that? Oh, you're all so sad now, I remember. Yes? Feeling good about that? All right, well, logs are going with some blue today. Okay, so today we're going to look at the graphs of exponents and the logs, okay, and see what happens. So, first thing we want to do is grab my calculator back out because I put it away. We don't have a graph, or we don't have a function. Somebody give me an exponential function. F of x is equal to, give me a base. 2. Sure, that'll work. Okay, so to graph that, I didn't do tangent, went to my y, and I said 2 to the x, right? And then I looked at my table and said, all right, at 2, I'm at 1/4, and at 1, I'm at 1/2. At 0, I'm always at what number? Yep, always at 1. And then 1, I'm at 2, 2, I'm at 4, 3, I'm at 8, and 4, I'm at 16. Okay, so if I graph that at -2, I'm going to be at 1/4, and then 1/2, 0, 1, 1, 2, 2, 4, 8. 4 is going to be right off. Easy peasy, right? You guys are like masters of graphing those. Okay, now if I want to do the inverse, what would I do to my table? And where's... Yeah, switch my x and my y. And so my x would be 1/4, And my new y is going to be -2. So at 1/4, I'm going to be at -2. Then at 1/2, I'm going to be -1. 1/2, I'll be at -1. At 0, I'm sorry, at 1, I'm going to be 0. At 2, I'm going to be 1. At 3, wait a minute, I flipped those around, didn't I? 1 to 2, 2 to 1, there we go. 4 to 2, 8, 3, 16 to 4. That's the hardest part, in my opinion. Okay, so I go to 4, and I'm at 2. 8, I'm at 1, 2, 3. And at 16, I'm going to be at 4. And my graph is going to look like that. Okay, perfect. Now, on my f of x, my blue one, where is my asymptote at? What is the asymptote? Beautiful name. Yeah, it's at y = 0, because that's the barrier, that's like the wall that's going to come up to, but it's never going to quite touch 0. So my asymptote's at y = 0. Now, for my inverse in my green, where's my asymptote going to be at? Is it just going to keep rising as it goes to infinity? Yeah. Where is it approaching but it's never going to touch? What's this line going to be called? Yeah, that's the y-axis, so that becomes x is equal to 0. Okay, does that make sense? Okay, now, looking at these two graphs, they look like a reflection of each other, right? Would you agree with that? If I folded my paper to get them to line up on top of each other, let's see if I can actually do this right. Okay, I was close. I get this fold line. That's close. It's really got to be like this. What is that line? That's your y = x. And remember when we were doing inverses for regular functions? They also were a reflection of y = x. Okay, so inverses, that's true no matter what. Okay? Does that make sense? All right, now let's look at another one. If I have f of x is equal to 3 to the x, let's change our y equal to 3. Take a look at my table. And -2 is going to be 0.11. -1 is 0.33. 0 is 1. 1 is 3. And 2 is 9. Alrighty, so let's plot these. 0.11, that's just going to be darn near close to my graph, or to my axis. So I'm going to put it right there. Because at -1, I'm at 1/3. So it's got to be a little bit higher. And as long as we're estimating it closely, that's cool. That's going to be good enough. Because it's still going to give us the shape of the graph. So at 0, I'm at 1. 1, I'm at 1, 2, 3. And 2, I'm at 9. All right, now let's do our inverse. Where do you think it's going to be? In which quadrant? Remember, we have 1, 2, 3, and 4. Which quadrants do you think this is going to be? This was quadrant 1, 2, 3, and 4. 3 and 1? Why? Just wondering.
It's like the last graph. Oh, 4 or yeah,
4 and 1, yeah. Okay. Which, if you think about it, if I have my y equals x line of reflection, and I fold it in half, yeah, it's going to throw it into here. So, if my x is now 0.11, and we're still using that inverse function notation, I'm at -2. At 0.33, I'm at -1. At 1, I'm at 0. At 3, I'm at 1. I'm at 9. I'm at 2. All right, so let's plot these. So at 0.1, I'm at -2. 0.33, I'm at -1. At 1, I'm at 0. At 3, 1, 2, 3, I'm at 1. And at 9, I'm at 2. And again, gives me a good reflection if I kind of graphed it. My arrow's a little off one. All right, so where's my asymptote for the blue line? Again, y equals 0. Where's the asymptote for the green line? At x equals 0. Notice the pattern? Okay, always, always, always. That's where they're going to hit, kind of thing. Okay, and again, it's reflecting over y equals x. Okay, and the special name for the inverses of exponential functions are logarithms. Okay, so looking at my inverse and my green graph, what is my y-intercept going to be? This is my y-axis. Where? No, the actual y-intercept. Where does it cross the y-axis? It doesn't, right? So this time, there's no y-intercept. Remember when we were doing exponentials, there was always a y-intercept, but there's no x-intercept? This time, it's reversed, which, since we're flip-flopping the x and y, it makes sense. Because what's my x-intercept going to be? Where did I always hit at 1, 0? Okay, the general trend of the graph on my green line, what is it doing? Is it increasing? Is it decreasing? It's going to go up, right? Because we're reading right to left, so it's increasing. Okay, now, again, think back to what we did for the exponentials. What was the domain for my exponentials? To infinity, and my range was from 0 to infinity, right? Okay, so if I'm flip-flopping, the domain for my log inverse is going to be, where do I start? at 0, right? So this time, the domains, is from 0 to x to infinity, right? And then my range, I'm coming from negative infinity and I'm going to infinity. So my range is just flip-flopped. Make sense? All right, one more. Okay, so the actual definition of the log of the actual equation definition log. Now let me make sure I'm putting it into the right format. Is going to be that we have, log, you always put log to say, hey, it's a logarithm, okay? And then we use everything else in our exponential, okay? So the log b, because it's the base of your answer, is equal to how to your exponent. Okay, so if I have f of x equals 2x, all right, that's really like saying y is equal to 2 to the x. Would you agree with that? Now, using this formula here, the inverse of the function is going to be log. What's b? What's my base? 2. And then y is equal to x. That's it. Okay, that's the start. Okay, so the f of x equals 3 to the x would be the log has a base of 3, my y equal to x. Easy peasy. And so go back, label your graphs with the equations, and then you get to just rewrite the equations as your homework tonight. Easy peasy? Good? Alrighty. Questions? Yes? Yep. So my inverse is going to be what? Log's always first. What do I do next? Yep, because my base is 6. And then y equals x. How easy is that? E is your base. E is still your base. E, remember, E is a number. Just like you can have log with a base of pi. Yes?
Do you keep the 1/2 in parentheses?
If you want. If that helps separate it out. When you're putting the base down, you're kind of doing it as a subscript, so it's like the little number lower. So it all depends on how what makes you see it better. It's all good. What other comments or concerns do we have? Good questions, you guys. Life is good? All right.